On this one, we're looking at an equation and we're trying to solve for the variables. So in the first case, let's look at the equation we're trying to solve. 2 parentheses x minus 3, close parenthesis, followed by minus 17 equals 13 minus 3, and then parentheses x plus 2. We talk about solving an equation. In this case, the letter that we're trying to solve for is x. And to solve an equation, we want to get what we're trying to solve for by itself. So in this case, we want to get x by itself on one side of the equal sign. In the process of doing this, if we have parentheses, usually the best thing to do is to deal with those first. So in this case, we're going to take, for instance, the 2 that's in front, and we're going to do what's called distributing the 2 into the parentheses. That's going to multiply by 2. We'll do the same for 3 over here on the other side of the equation. We'll distribute the 3 and multiply through by that. And what we'll have after doing that is 2x minus 6 minus 17 equals 13 minus 3x minus 6. Now again, we want to get x by itself on one side of the equation. So let's start putting things together. On the left side, I'm going to take the negative 6 and the negative 17. And if we do negative 6 minus 17, we'll get negative 23. So we'll write 2x minus 23. On the other side, we have 13 minus 6. And if we do 13 minus 6, we get 7. And then we write 7 minus 3x. Okay, and from this point, we'd like to get all the x's on one side. So we could do that two different ways, but in this case, I'm going to add 3x to both sides. I'm going to add 3x to go the opposite of subtracting 3x. So negative 3x and positive 3x will go away when we put those together. So on the other side, we're going to add it with the 2 to get 5x minus 23 equals 7. And then I'm going to take the negative 23 and I'm going to do plus 23 to both sides. Again, we're trying to get only the x on that side. So if I add 23 to both sides, that'll make that go away. So I'll write it as 5x equals 30. And we're almost done. We just need to get that 5x to turn into just regular x. And to do that, we need to get rid of the 5. Now, since it's a 5 in front of the x, and I'm trying to get rid of just the 5, 5 is multiplying with the x. So to do the opposite of multiplication, we divide 5 to both sides. That leaves us with just x is equal to, and then 30 divided by 5 is 6. So x equals 6. On the next one, we have fractions. It goes x over 2 equal to x over 3 plus 1. So first thing we're going to do is we're going to get rid of fractions. Now to get rid of fractions, we have to do basically the opposite of multiplication, opposite of division, which is multiplication. So we need to multiply through by something. We call that thing that we're going to multiply by the LCM, or least common multiple. And that would be the least common multiple of the denominators. The least common multiple in this case is the number that basically that both the denominators will divide into. So you've got a denominator of 2 and a denominator of 3, and you want to think of a number that both 2 and 3 divides into. And that number would be 6. So 6 is the smallest number that both 2 and 3 divide into in this case. And that's what I'm going to use to multiply both sides by the number, the least common multiple of 6. Because what I do to one side of the equation, again, I have to do to the other side. So if I multiply by 6, let's multiply the first fraction by 6, and we could write it as 6x over 2 equals, and then 6 is going to distribute to the other side across everything. We can write it as 6x over 3 plus 6. And we can divide the numbers. 2 divides into 6, 3 times. 3 divides into 6 2 times. So this would reduce down to just 3x equals 2x plus 6. And from here, I'm going to subtract 2x from both sides. And that would make it just 1x, or just x. And that would be x equals 6. And that's it. Here what we're going to talk about is what's called interval notation along with inequalities. So these are situations where we have greater than or less than. So over on the side I have some of the information about interval notation and how when you're dealing with things like greater than or equal to or less than or equal to, we're going to use brackets, which indicates that the number is also included in the interval, which is a part of having the equals inside of that greater than or less than or equal to. On the other hand, if it's strictly greater than or less than without the equal to included, then we're going to use parentheses when we write our interval notation. Parentheses are there to indicate that we're not including the number. We'll include less than, we'll include greater than, but not the number itself, because we're not also equal to it as well. So to get started, let's look at this one here, where we just have a statement such as x greater than equal to -3. What's going on here is we're saying all the numbers, including the number -3 and greater than that number. So if I show this on a number line, we're going toward the greater than side. So we'll be going from 3 onward toward positive infinity. And since we have equal to in that, we'll write it as a bracket at that location. So we write a bracket at -3 pointing to the right toward the greater than direction. And that's how we indicate on the number line x greater than or equal to -3. And in interval notation, we write that as bracket -3 comma infinity. Now, one thing we always use with infinity is a parentheses in interval notation. So we're going to put a parenthesis there. Bracket -3 comma infinity. That's an interval notation of for x greater than or equal to -3. On the other hand, if we say less than, for instance, x less than 2, let me show what that looks like on the number line. And so we're pointing in the left direction, the less than direction. So I'm going to put a parenthesis here, pointing to the left, and I'll shade the number line in, off toward -infinity. Now I'm using a parenthesis again because I'm not using the equal to with the less than, it's just less than. So what we're going to be able to do then is write this in interval notation as parenthesis. What's on the left side is -infinity, comma, 2, and then close that up with a parenthesis. That's the interval notation way of writing what we see on the number line. Now, if we're going to be looking at a inequality that we're trying to solve, it's much like an equation that we try to solve. We try to get x by itself on one side. So I'm going to start out in a similar way that we would have for solving an equation. I'll start by distributing the 2 across the parentheses and write it as 6 minus 10x less than or equal to 16. And then I'm going to subtract the 6 from both sides, leaving just the -10x on its own, less than or equal to 10. Now what I need to do is get the 10 away from the front of x. So I'm going to divide both sides by that number, -10. That makes it go away. And we're going to write x on its own. And one thing that will be different now when dealing with inequalities is I'm going to switch this from a less than or equal to a greater than or equal to. 10 divided by -10 is -1. Now, why did I do that? Why did I suddenly change it from one to the other? It's because I divided both sides of the inequality by a negative. So whenever we divide both sides of an inequality by a negative, we flip the direction of the inequality. So here I flipped it from less than or equal to greater than or equal to. Now, to follow up with this, I'm going to take the inequality and I'm going to show that on a number line to show what it will look like. Here again, we're going to use a bracket located at the number -1, opening toward the right, toward the greater than direction, toward positive infinity. Interval notation would go bracket -1, comma infinity, close parenthesis. Here's another one. It goes 3x plus 11 greater than 6x plus 8. Here's what I'm going to do first. I'm going to go ahead and subtract 6x from both sides. We have to get all the x's over to one side, so why don't we subtract the 6 over? So that'll make it look like -3x plus 11 greater than 8. And then I'll subtract the 11 over to both sides, bringing it down to just the -3x on its own, greater than -3. And like we would solve an equation, now to get rid of the number in front of the x, we'll divide it out to both sides. So divide both sides by -3, leaving it as just x. But again, since I divided by a negative on an inequality, we're going to flip it to a less than, x less than positive 1. So that's our solution for x. I'm going to show this on a number line. Since it's less than, we're going to use a parenthesis pointing to the less than direction toward the left, shading the number line toward negative infinity. So in interval notation, that would go parentheses, negative infinity, comma 1, close parenthesis. This one's a slightly different setup because it actually has two inequality symbols. It looks like 1 less than or equal to 3x minus 2 less than 4. The way we're going to solve this still works similar to the way we would solve an equation, get x by itself. I'm going to start to get x by itself by adding the 2. Because of the -2, I want to add it to get rid of it. But now I need to add it both on the left and the right side of the inequality. So we're going to add 2 plus 1 to get 3 less than or equal to 3x less than 6. And then to get x by itself, we need to divide by the number 3. And we'll divide across everything by 3. That'll make it 3 divided by 3, which is 1, less than or equal to x less than 2. Okay, and so let me illustrate that on the number line. It's a slightly different look to it here because we only have the numbers between 1 and 2 to worry about here. 1 is the smallest number and 2 is the biggest number. For 1, we're going to use a bracket, and for 2, we're going to use a parenthesis. And I'm going to shade everything in between those numbers. And in interval notation, it would go bracket 1, comma 2, parenthesis.